Hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet, and it's me, Richard here. Okay, we are still continuing this question. It says that a small metal-coated sphere A mounted on an insulated stand and charged by addition of that number of electrons. And from the previous calculation, we realized that when this sphere acquired this number of electrons, it attained this charge, which is minus 1.28 times 10 power 8 coulomb. Then it is placed near another identical sphere B, carrying a charge of this one, plus 8 non-coulomb, and is placed at a distance of 40 millimeter. The spheres A and B were brought into contact and then separated. Then the question says that calculate the charge acquired by each sphere. It is very important to know that this charge is negative. I have to remind you that when an object attains or acquires or accepts electrons, it becomes negatively charged. And this one is positive. So what are we going to find out? We are going to find out the charge each will have after touching and separating. So you have to remember here that the charge 1 is negative 1.28 times 10 power 8 coulomb. And the charge on Q2 is 8 times 10 power minus 9 coulomb. Now, what do? We have to remember that when these ones touch and separate, they'll both get the same charge, the same magnitude, and the same sign. Okay, what equation do we adopt? The question says that Q1 plus Q2 over 2 is equal to the charge on each. What is Q1? It is 1.28 times 10 power minus 8. It is very important that the signs are indicated. So then plus what? Plus positive, which is 8 times 10 power minus 9. You divide by 2. What you get here is going to be the charge on each. And there we are. This is the charge which each sphere will be having after touching and separating. Okay, then let us look at another question, the follow-up question on this one. So comes this question. It says, name and state the principle used to calculate the charge on each sphere after touching and separating. We have to remember that the equation we used is Q on each, which is equal to Q1 plus Q2 over 2. That's what we have used. The question is, what is the name of this law or this principle? It is called the principle of conservation of charge. Let us put that one down. So that is that. And how does it state? It states that the charge, the net charge of an isolated system remains constant or is conserved during physical processes. This principle literally says that no charge is lost or no charge is created. Charges are just transferred from one point to another. So if you have a closed system and objects come into contact and they are charged, the total charge before coming into contact is going to be the total charge after coming into contact. So let us put it down. So that is that. The net charge of any isolated system is conserved. Okay. So comes this question. It says that identify which sphere lost electrons and which one gained electrons. Okay, to understand this, you have to remember that all charges are created by movement of electrons. If you have a negative charge, what does it imply? That charge was created by addition of electrons. And a positive charge is created by losing electrons. So in other words, all the charges we have, positive and negative, are created by movement of electrons. So you have to know that a negative charge implies excess electrons, and a positive charge implies deficiency of electrons. And the electrons, they move like Brownian motion principle. They move from where they are highly concentrated to where they are of low concentration. So when you look at A and B, which one is having more electrons? Is A. It's negatively charged. And positive means lacking electrons. And you have to remember that electrons are moving from where they are highly concentrated to where there is low concentration of electrons. So they are moving from A to B. So which one is losing electron? It is A. And which one gained electrons? It is B. And with that, I would like to thank you for your time. The channel is PSSB. It is me, Richard, here. See you next time. I will not get tired of reminding you to subscribe, to share, to like. We are simply the best. Bye-bye.